Today, we're going to look at one-day motion in great detail. I told you the other day, one-day motion means a straight line motion and it has two directions. As I told you, it is bidirectional. It could be forward, backward, up or down, and back and forth, etc. So this is what we call as one-day motion. Now hereafter we are going to fully focus on one-day motion. And in this, the acceleration is bound to be only tangential acceleration. For example, the other day I told you this is along the straight line. That's why it's called tangential, number one. Number two, we will not put this subscript 80, but we will confine our attention only to A. So we know that we are referring to only tangential acceleration, and we put the symbol only as A. So I don't want you to mistake it. Now, when I discuss one-day motion, now I want you to be very careful because I'm going to use those techniques like calculus, for example, derivatives I'll be using, integration I'll be using, and this is presumed that you have a basic idea of those techniques. Now, let me now start with the expression or the so-called equation V is equal to dr by dt. Now, when I write V is equal to dr by dt, I can rewrite this as integ dr is equal to v dt. And I integrate it on both sides. Now, I will write say 0 to t. This may be r1 to r2. You know that integral dr is r and the limits are substituted like this. This is retained as integral v dt 0 to t. Now if I substitute, you know that you are going to get r2 minus r1. But you know r2 minus r1, final position minus initial position, therefore that is nothing but now this is a very important equation, remember, in kinematics. Very important equation. When I start off with the fundamental definition of V is equal to dr by dt. Now let us look at the next equation. This I'll write it somewhere in the corner so that we can use it whenever we need it. Now the first definition I have it in V is equal to dr by dt. The second definition, A is equal to dv by dt. Now this A is equal to acceleration is equal to rate of change of velocity. Now if I rewrite this, I'm going to get like this. Integral dv is equal to integral a dt. Therefore I'll put that times at this initial velocity u, final velocity v. Now if I substitute this as a v, now you have the limits. Now this is integral a dt 0 to t. So I can write this as v minus u is equal to integral a dt. Now, why I am complicating the matters is you will never ever get a doubt in what formula to use, what formula not to use, etc. So v minus u is equal to integral a dt is at another very, very important expression. Right? Now, in the same way, I'll take A, which initially I wrote it as dv by dt. Now this can be written as dv by dr into dr by dt. But this dr by dt is nothing but v. So I can write this as, now always remember, a you can write in two ways, dv by dt, other one is v dv by dr. Most fundamental, any time during your course of study, you should always remember this. Like the way you remember those two tables whenever you're asked to give those values. So a is equal to v dv by dr. Alright? Now I rewrite this as integral a dr as before, limits and this same limits. So v dv I can write it as v square by 2. I will substitute these limits at the appropriate time. So how can I write this? If I substitute, what do I get there? V square by 2 minus u square by 2 is integral a dr. Or I can write it as v square minus u square. Look at these three questions. S is equal to integral v dt, v minus u is equal to integral a dt, v square minus u square is equal to twice integral a dr. Now, these are the three equations that you should always remember, right? How these are different from what you have learned in, say, 9th standard or maybe 8th standard, I will tell you a little later. Now, first of all, these three questions, and then as I told you, never forget this a dv by dt, a is equal to v dv by dr, and v is equal to dr by dt. Now remember, how many equations are there if you see that? These are by definition. These are after processing. And these are what we call as kinematic equations, right? Kinematic equations. That was what you have to always remember. It's okay? Kinematic equations. Now, I can discuss a special case here. What is the special case? I am taking a to be a constant value. Since this is a 1D motion, remember, constant acceleration. So obviously, if I write v minus u is equal to integral a dt, means I can write it as constant, means you can take it outside the integral, and 0 to t it becomes at. So now this is nothing but your famous equation v is equal to u plus at. Now this is, I know that it was taught to you. You probably derived this in a very simple way. I'm not going to get into that detail at this stage. I want you to learn everything in kinematics only through these relations. Because this v is equal to u plus at, if you get used to this, you will land into troubles when a is a function of time, when a is a function of r. So you have to be careful. But this is valid universally. So I call them as universal equations of motion in kinematics. Now this is very, very important for you. So you got v is equal to u plus at, right? Now, if v is equal to u plus at, how can I write integral v is u plus at dt? Now I can write it as integral u dt plus integral at dt, right? Now u being anyway constant, so I can take it outside, and integral dt is t, and this is a constant I take out, and integral t dt is t square by 2. Now look, you have got that second equation of motion that you have already learnt in 9th standard. But as I said, this is only a special case, and that's all you learnt in your school days. Now it has to be slightly different. And the way you memorize also, I don't want you to memorize these things. In fact, it is better that you memorize this if you can. And it's not very difficult to memorize it as well. If I look at this, this is the second equation I got. Now look at another equation that you have here. When a is constant, you have v square 2a integral dr. So obviously any two limits are r1, r2, we don't know. So that would be equal to 2a into r2 minus r1. And you know that r2 minus r1 is, well, this is your famous third equation. I think I'm sure you will appreciate that these are all actually derived from this as a special case. But whenever I ask you, when a is constant, we call them as uniform accelerated motion. Uniform accelerated motion. That means a is constant. And what are the equations that you can write here? U plus at, s is ut plus half at square, and v square is u square plus 2as. When we confine our attention to uniform accelerated motion, then we automatically take them down straight as they are, right? But when a is not constant, then the trouble comes, you can't use this. So first I want to do a variable a. If a is variable, how these equations are going to behave, you can see for yourself. For example, now this is already known to you now. Now I will not go with the a as constant. Instead, I would write it as variable acceleration. What is variable acceleration? A could be a function of time. A could be a function of position or displacement. A could be a function of velocity. All these three are possible. Now I want you to understand that for each of these things I'm going to give you one or two examples so that you will never get a doubt. And also, as I said, I keep telling you very often and as many times as possible that you have got to bear in mind that these are the equations of motion, not anything else. Because anything and everything can be derived from these set of equations in one-day motion. Okay? So now let us come to this one by one. First we will take a as a function of time. I am giving an example. A is equal to say 60. Suppose I have given, and say u is equal to 10 units. U is equal to 10 units. Then find where velocity at t is equal to 4. For example, now the wrong way to do, I am putting this here, wrong way to do. To put v is equal to u plus at. Now if I substitute, I will get 10 plus 60, 60 square, and t4, 4 into 4, 16, 6, 96, so you are getting 106. I want you to understand that this is wrong way because you are using this formula which is in your mind almost for years together. What is the correct way to do it? The correct way to do it is go with this expression. What is that expression? Now look at that. V is equal to u plus integral 6t dt. And now u is given 10 and we will take it as 0 to t, and if u is substituted as 10, then 10 plus 60 square by 2. This is 0 to t, therefore 10 plus 3t square is your v. Now I want to know what is t, v at t is equal to 4. So I will take this. So what do I get? 16 into 3, 48 plus 10, 58 units. Now this is the correct way to do it. And you remember, what is the, see, these are the fundamentals. Now I never want you to go wrong, because I have seen once you come to 12th standard and do your electrodynamics, and suddenly you come across some kind of function of this nature. Now you are tempted to write v is equal to u plus 8 and s is equal to ut plus half at square. Now this is not what I would expect you to do once you learn from my classes. I want you to understand that the equation, the only equation, the universal equation is this only, 1, 2, 3, nothing else. Even if somebody gives a is equal to only 6, even then you can use this. You are going to get perfectly correct answers when you use this. I hope this point is clear to you now. Okay, now fine. So I am erasing this part. So what is it that you have got here? Now we, as a function of time, you got it. The same problem, mind you, I repeat, in the same problem, I have actually initially asked you what is velocity at t is equal to 4. Now I may ask you, what is the displacement during first 2 seconds? What is the displacement during first 2? In fact, I am now working on the same problem. I am extending this problem. First we found out velocity. Now if I want to get the displacement, I will use this. How? Now look at that. As I told you, displacement, there is only one relation. So S is equal to integral 10 plus 3t square, say dt. Now, as before, put it from 0 to t. Now what do you do? Simply obtain this. So you get 10t plus 3t square means t square is t cubed by 3. 0 to t, 3 gets cancelled. So that gives you, this is the displacement expression. And 0 to 2, he said. So, how to get the answer? I erase this again. Instead of 0 to t, you write 0 to 2 to get the displacement during first 2 seconds. First means initial. 0 to 2. Otherwise, let them say 2 to 4, 2 to 5. So you put 2 to 5. 3 to 8, you put 3 to 8, whatever they say, you can do that. And now you substitute simply in those limits, and then you get, this is 20 plus 8 minus 0. So 28 units is the displacement. Now, what is this that I have given you in this example? If you see carefully, I have taken a case where a is a variable acceleration, and that too a is a function of time. A is a function of time. Then first, every time, sometimes they'll ask you, a is given, what is displacement? never directly rush to that part. You have always got to first get velocity as a function of time and then use this equation to get displacement as a function of time. You understand this? So, because you use these things, I think if you keep using it, say 3 to 4 times, or 5 times, 6 times, I'm sure you get used to these equations, and that is very, very important. Now, for example, A I have given you as a function of time. So from that you could find out what is your velocity and what is your displacement. In a similar way, I'll give you A as a function of say displacement or position. Suppose I am saying A is equal to 12 r square, something like that, some arbitrary value. Okay, and here initial velocity is, I am giving it as 0. So what equation do I use? V square is equal to 2 12r square dr. Yeah, you have already this equation at your disposal. Directly put A is equal to 12r square. Now what does this give you? 2 into 12, 24. R square dr is r cube by 3. And the whole answer becomes 8r cube. Now, V is equal to under root 8 r raised to 3 by 2. Now, V as a function of r, I have got it here. Now, if they ask you what is the value of velocity at r is equal to 5 or r is equal to 10, you understand? Or r is equal to 8. Anytime they ask, I think you can use this and get that value. Is that clear to you? Now, one can ask further, what is the position as a function of time? Now, A is given as a function of r. I got V as a function of r. Now I will try to get what? Position as a function of time. The same problem. Remember, the same problem I am extending it. First step I did for velocity. Second step I am going to do it for position. Now, very simple. You have what is V? dr by dt and root 8 r raised to 3 by 2. So now look at this. V is equal to dr by dt is what I am trying to use it. V is equal to dr by dt. Now, if I rearrange this and write it as r, if r raised to 3 by 2 comes onto this side, r raised to minus 3 by 2, and this is under root 8 dt. Now, of course, you have to integrate it on both sides. Now, this is r raised to n plus 1 by n plus 1. So, minus 3 by 2 plus 1 by minus 3 by 2 plus 1 is equal to root 8t. So, this is minus 1 by 2, this is minus 1 by 2. Now if I substitute, minus 1 by 2 becomes 2, so minus 2, and this is by root r is equal to root 8 into t. Right? Now, how do you rewrite this? Minus 2 under root 4 is equal to root 8 t root r. Now, this is root 2, isn't it? Root 2. So, what are you getting? Minus 1. Now, if you square on both sides, 1 is equal to 2rt square. R is equal to 1 by 2t square. This is the way we try to get position as a function of time. Don't get confused with this. Once you are familiar with integration, I'm sure all these problems are going to be very, very easy for you. Now, first of all, what is it that I did look at that? In the first case, when A is a function of time, I first found out velocity, then I found out displacement. Then in the second case, when A is a function of position, I first try to find out velocity as a function of position. Then immediately from that, I wanted to get how to get the position as a function of time. So I made use of this. In fact, you see, you may come across any number of problems, but the equations that you'll be using only are three. Never get carried away with what the book gives. Now the book gives in the name of shortcuts, number one, likewise. What is that shortcut you see? What do you mean by shortcut? So they say for everything they give a formula? Ridiculous. This is not a proper way. How many formula are you going to memorize? So, but if you are familiar with this and keep working on this formula very, very thoroughly, then I'm sure these things will remain in your mind. You can work out any problem at any stage. Remember that. So first two functions we tried. What? Acceleration as a function of time and acceleration as a function of r. Now acceleration as a function of velocity. What do you mean? I don't know. I'm just trying to give you, say, something like this. A is equal to v raised to 4, 12 v raised to 4. Suppose the acceleration is a function of v. Now, they may ask any question here. I'm not giving you the question. Why? When a is given as a function of velocity, I can use 1 dv by dt. Well, if v you want to get as a function of time, use dv by dt and rewrite this expression. How do you write that? Is equal to 12 dt. I have rearranged, integrated on both sides. What are you getting here? Minus 4 plus 1, 3, minus 3 is equal to 12t. Now, generally, they may give some value. Supposing he says initial velocity 0. So I'll put 0 v, likewise 0 to t. And then what do I write? Here, if I want to work it out and simplify, I can write it as minus 1 by 3v cube is equal to 12t. Or v cube is equal to minus 1 by 36t. This is how you have to get v as a function of time. They can give not this v raised to 4, any number of functions. This is the only methodology that you have. Alright? Now,